This video has been made to help you learn how to solder. Whilst it won't make you into a pro solderer, it might help you avoid some of the pitfalls along the way. First thing to discuss is the required tools. The first thing is a soldering iron. Try and avoid the big chunky ones that you would use in your garage on your car. These aren't temperature controlled and they're not ideal for working on small components and circuit boards. The same can be said for one of these soldering guns. I have one in my garage. I very rarely use it. It's like an emergency use only for things on my car. I would never use it for soldering a circuit board. At a push, the smaller ones could be used, but if you're going to do a lot of soldering, it's worth investing in a decent soldering iron or a decent soldering station. The first soldering station here I used for many years. It's temperature controlled and will last you a long time, and it's a very good soldering iron. I moved away from that onto this type of soldering station because it had hot air as well, which means I can do surface mount components, and also it's got like a built-in power supply so I can test components and check voltage and things like that. They're not a huge amount of money. I think this one cost me about £80 on Amazon, so it's worth spending the money to have a decent soldering station. After that, you need a sponge. This is so that you can clean the tip of your soldering iron when it gets dirty from soldering. And another important part is the actual solder. There are lots of different types of solder out there. Some have got lead in, some haven't got lead in. The ones without lead, to be honest, I find them to be hopeless. So the one I get is made by Wharton Metals in the UK, which is 63% tin, 37% lead, 1.2mm in diameter, and it's called a fast flow 2%, which is the amount of flux it has in the middle. I've been using this for years and it just works exactly how I want it to work. It's fast enough to keep up with me, it's not messy, and it just works really well. But you might have different preferences depending on how you solder. For health and safety reasons, I do have to mention lead is not good for you. That's why a lot of people now are selling lead-free solder and trying to use lead-free solder. It's really not pleasant. This is why it's important to try and use some kind of ventilation, fume extraction. Ideally, for health and safety, you should probably be wearing gloves. So just bear that in mind. Lead is very toxic, but it does solder really well. When you are soldering, there will be a lot of nasty fumes that come off the work that you're doing. Solder, when it melts, has lead in, it has all sorts of chemicals in for the flux, and the actual components you'll be soldering as well. It's just not pleasant, so you really need some way of keeping that smoke out of your face. I have one of these, which is basically like an extraction fan with a built-in carbon filter. You don't have to buy one of these. At a push, you could do it in a well-ventilated room, but the trick is really just not to breathe the fumes in. If you see the smoke coming towards you, I usually just blow it out the way. You want some cutters for trimming away the excess parts of your components when you've soldered them in, and it's worth having some nice electrical ones because they're not a lot of money and they're better than the massive side cutters you might have in your garage. An optional extra, depending on how good your eyes are, is a pair of these magnifying glasses. These are really good. They're not a huge amount of money. I think there's something like £15 off eBay I paid, and they come with different lenses, so if you're doing work that's very small, you can put them on. They've got a built-in LED and you can get a really good view of the component that you're soldering. Another one that people may have not seen used before in soldering is blue tack. I'll show how this gets used later on, but it's absolutely one of the most useful things when you're soldering in the world. If you forget to solder a component and it's sticking out on the board too much, blue tack's there to help you, and I'll show you how that gets used later on. And last but not least, for those times when things go slightly wrong, a desoldering pump. Again, these aren't a huge amount of money, £6–7 off eBay, and they are essential for getting rid of excess solder or for desoldering components. I won't actually be covering desoldering components today, but I will show what happens if you get too much solder on a component as you're making it, and this is where you'd use a desoldering pump. First thing I do is turn my soldering iron on. I solder at 400 degrees because I find that if I use quite a hot temperature, the components flow really quickly and really well. Otherwise, if you have too cool a temperature, you find that the heat will soak into all the components, things start melting. It's not a good place to be. So 400 degrees works for me. That's 400 degrees Celsius. Turn your soldering iron on, get that getting up to temperature, and then you can get the rest of your components ready. It sounds obvious, but before you start, make sure you've got all your components together. The last thing you need when you're in the middle of soldering is to suddenly have to stop and go rooting around looking for LEDs or transistors or something, depending on what job you're doing. Okay, the first thing I like to do is decide which components I'm going to use in which order. It always makes sense to try and use the lowest component first, and when I say lowest, it means the one that sits lowest on the board, and I'll show you why. So I've got these resistors here. Now when they sit on the board, they're going to be quite flush to the board. So if I get those ready by bending the legs over, you'll see exactly what I mean in a second. And if I put those through the board, apologies if it goes out of focus here, they should go in like this. And now if I turn this board upside down, it can rest on the surface quite happily without me having to worry about the height of how far the components are sticking out. So get my soldering iron. And the first one, so this is where the actual main soldering tricks come in. So what I like to do first is make sure that your soldering iron is clean by wiping it on your sponge first, so it should be in like a nice silvery tip. And just to make sure you've got enough solder on, just touch the solder a little bit on there. I'm not going to do it yet because I want to explain something else. What you're trying to do is make a thermal contact between the two components. So if I zoom in here as I do this, you're trying to make a joint between the metal of the component and the metal that's exposed on the actual board. So the way you do that is, first of all, make sure there's some solder on there, so that will give you a good thermal connection between the two. And what you're trying to do is not get solder from the tip onto the two components, but just use the solder that's on there to make enough heat, and then when the solder goes in, it effectively bridges between the two, and then it makes like a nice soldered, well, almost like a welded joint. Okay, so again over there, and again over there. I'll try and use a macro lens in a minute to show the actual the joint. So that's my first couple of components done, and they're nicely flat. So I then chop them off, chop the ends off here, get them out of the way. I'm a bit ham-fisted at the moment because obviously I've got a camera right in the way of where I'm trying to solder, so I don't normally do this so awkwardly. Next thing is with the component is, next one's height-wise are the LEDs. So if you look on the board, you might be able to see there's a negative and a positive. On an LED, the cathode, which is the negative, is always the shorter length. So if you think like a plus and a minus sign, the minus sign has, if you were to draw them, a minus sign has a lot less kind of line than the plus, which would be 2 lines. So that's where your shortness comes from, if that makes sense. And that works with all electronic components. So if something has a shorter leg, it means it's the negative. Again, I'm just struggling with the camera right in front of me. So push that right in the way, all the way through, and Bob's your uncle. There go the LEDs. Now a trick I'll show you here is just to solder one pin at a time. It's not actually that important on this component, but I'll show you in a minute why. So if I just solder one pin at a time, just have a quick turn it over, make sure they're all flush, which they are, and that's fine. I can now solder the other side. I normally have this, hold this soldering iron much further down, but I've got to make allowances. Right, so that's those guys done. Get rid of my bits there. If you want to neaten up these bits you've chopped off, see how they're a bit kind of big as such, you can just gently touch them again. The soldering iron will just make them into like little blobs, which might look more pleasant. Okay, now the next thing is these. Now, the thing about these is they're quite a hard, well, they're harder to solder than the other components, because most of the LEDs are kind of pre-tinned. If you follow, they've got solder on the outside of them, whereas these don't. Even though these are gold plated, they'll conduct heat quite well, but they don't solder as well as something like an LED or a resistor. And I'll show you why in a minute. So again, I can put those down. If you were to just try and quickly solder them, they wouldn't solder that well. Now this is where your blue tack comes in as well, incidentally, because obviously I don't want that on that angle, because they're not going to sit very well. I want them to be kind of sat like that. So this is where you can use your blue tack, because it's quite pliable, sticky, and it doesn't stick too much. And I can put that there like that, and that will hold it where I want it to be held while I'm soldering. Now, with anything like this, where you've got multiple pins and it can move around, you use a welder's trick, which is like where they do a spot weld first of all, before doing the whole weld. So in this case, if I just do one pin like that, and I'll have to hold it on for a second to get it to transfer to both. That is one pin only, but that's enough to make sure that everything's sat flush. If it's not, then what you can do is you can hold the component, don't hold the pin that you're going to solder because it'll be a bit hot, and you can just loosen that and then move it around if need be. But once you're happy with the one pin that's soldered, you can then go in there and solder all the others. Again, what you're doing with the soldering iron here is you get the soldering iron behind where you want to go, and I touch the solder onto the soldering iron and then move it over onto the component, because that ensures the solder starts to melt and flow before it then goes on to the other to the actual components. And if you can see, what I might try and do is zoom in a little bit here. No, it's already zoomed in. But what it actually looks like is the solder will start to flow on the joint, and then you'll see it kind of suddenly rush between the two parts. So it'll rush between the pin and the base underneath. And what I'll do in a minute, not on this one, my blue tack's let me down a little bit here, but it's still holding it in the right place. And the thing is, once it's got those first pins soldered, it's not going to move, the components aren't going to move anyway. Okay. And that is done. That's that bit. So that's those done, so I'm happy enough with those. I might tidy up this one up here, but it's fine. So, next component in order of height is the screw-in terminals. Remember to get them the correct way around. Now this is where the spot welding technique can really help you, because if I put that upside down like that, they will actually hold that blue tack. I can just, now this is easier to see actually, the solder flow that I'm talking about. If I was to just quickly throw that on like that, you'll see now, and I'll do that on purpose and leave that one for a minute, and I'll show you what I'm on about with a dry joint. So, but if I let it go all the way across, you'll see it flow over. But with this one, I mean, I knew that one was going to be okay, which is why I soldered both sides. But with this one, because I've only soldered, I've actually soldered both pins, but what you can do is if you only solder one, is it allows you to kind of twist these around to get them straight. So if you can see here, it's not all the way across to the pad. So it's not really a dry joint because it actually has got on the other side, but you want to get this completely flowed between both parts of the component, completely covering the pad. In the case of this particular component as well, it's carrying voltage, so you want as much solder as you can between the actual leg of the component and the board, so it's maximum, so there's the maximum amount of electricity that can transfer between the component and the board to do its job. So that's why you do that. Okay, we'll get this last bit. Now what I do with these generally is solder these outer bits first, the main bits that hold it onto the board, because then it's all secure then, and that takes quite a lot of solder to do that, but it also has the benefit of cleaning your soldering iron while you do it. So again, a bit of solder on there just to get the thing going, and then you're trying to touch between both components, fill any holes up. Right, and then you can move on. Once you're happy you've done that, you can do all these little ones. When I'm over the top of these, it's really is a lot easier. I'm about half a metre away at the moment. You don't generally need to clean your soldering iron constantly, even if it builds up like a bit of a dirty surface, which you can see on the back there, it's starting to build up a dirty surface. You're okay. What you can do is when you put it on the next component, you can almost scrape into that dirty surface with the component, and that'll show enough of the clean soldering iron to then make the joint solder. Ultimately you'll need to clean it, but it just means you don't have to do it after every single joint, because that would take forever. So it means you can just The other thing to watch out for, if you're doing a lot of them like this, you might suddenly find that they're getting harder and harder and harder to do, and you can't work out why. And what's happening is, obviously you're taking heat out of the soldering iron and putting it into the component. So if you haven't got a very good soldering iron, or you're a very fast solderer like I can be, then you can actually be ahead of how much power the soldering iron can get from the solder station. So sometimes it's worth just waiting for a second, use that opportunity to clean the tip for the sake of it, and then the heat will build back up, and then lo and behold, you'll be back to full speed again, and all the components will solder nicely. And that is, let's just do that one. And that is that board quite nicely soldered. That's almost all there is to it, to be honest. On this particular board anyway. But it's a good board to demonstrate because you've got a few different types of components, but you haven't got so many to be overwhelming. But they are kind of typical of most of the components you'll get. As I say, these ones here in the middle, they can be a bit of a nuisance, which is why you have to have quite a hot temperature, because if you don't have a hot temperature, I don't think they solder that well, and you end up having to hold the soldering iron for a long time, and all that does is soak heat into the component and into the board, and everything starts to burn. So in some cases, in most cases, the hotter the soldering iron is, the quicker you can just solder these without getting too much heat soak into other components. If you do have a component that's going to really heat soak, like the leg on a resistor or the leg on an LED, actually can act as a heat sink and slow you right down. So what you can do is you can put the component in place, you can chop the legs off, and that will actually help you solder as well, because there's the legs aren't sucking all the heat out of the soldering iron and taking the heat away from what you're trying to actually do. So often you can do that. And I'll show you a neat way of doing that just now. I'm just going to change these boards. Right, so here's another trick. If you've got a board where you're soldering LEDs and you've got a lot of LEDs, which some of the boards we do have a lot of LEDs, you want them to be neat and you want to make your job as easy as possible. So one trick I've been doing for a while is, if you can, get two boards the same. So you might have a spare board afterwards, but you can always have that as a spare or sell it, because generally the boards themselves aren't hugely expensive. So you've got your two boards, put them together, and this is tricky to do with a camera in the way. You get your LED, and you go through both boards like that. I generally will do the corners to start with, just to get the thing lined up. It's a lot easier once you've got it lined up. There we go. Then I populate that board with LEDs. And once the corners are lined up, the rest of it will be simple. And I'll finish populating this board and I'll show you why this is a useful tip. And that's fully populated. Now, one thing I like to do now, you've got to make sure you do not want these moving. So use your blue tack again. I'm going to use 2 mounts this time, because you really don't want these LEDs coming out halfway through this process. Okay, then use something like, I've got a drinks mat here which does the job. So I can push that in, make sure the LEDs go flush so that they're all pushed in. The boards aren't moving. Hope you can see that. And that's my two boards with my LEDs through. And now this is my little favourite trick that I like to do to save myself a load of hassle. It's not going to look good as I normally do because I've got limited visibility. But you'll see why you don't want these LEDs moving, because once you get to this point it's quite tricky if they all come out. And bear in mind, these haven't been soldered yet. That's absolutely fine, as long as all goes well. But I have done this several times, so it hasn't gone wrong too many times yet. And there we go. That's what I wanted to get to. I've got my two boards now. Very simply, and this is the trick, get a little knife or something between the two boards, And lo and behold, there are all my LEDs exactly the right height to solder. And look how easy it is now, because I've taken all those legs off. There's no heat sink effect from the legs. Get yourself on a nice angle and just go all the way through, run through each of these components. This doesn't just work with LEDs, obviously it would work if you had like a million resistors or something. But that's how easy it is to solder these things, and you don't have to worry about not being able to get your soldering iron in and having to chop them off as you go and all that kind of stuff. So this is why sometimes, for the sake of another, if you're soldering one of these boards yourselves, it's worth ordering an extra one, because it really can save you a load of time. You'll see how quick I do this board. So I would normally do them slightly quicker even. Remember, as I'm going, I'm scraping the soldering iron surface against the component, which is freeing any kind of oxidized solder off the tip. Make sure they look alright. Make sure I haven't missed any. Get those. Off comes your blue tack. And you have got one of those boards soldered, probably in quite good time. They're all flat, they're all straight, and they're all spot on. And that's my favourite little get out of jail free card that I use when I'm soldering. Right, I've switched to a macro lens to show you sort of a dry joint, but it's a bit tricky to kind of show it. But if you can see this component down here in the corner, well, this solder joint, it's not great. It's got way too much solder on it, and the solder doesn't actually go all the way around. That's typical of, if you ever open anything that you've bought cheap, like a cheap radio off the market or something, you'll probably find that a lot of the components will look like this, and it might just about barely be working. With a dry joint, what happens is you get solder between the two components, and it might make kind of a mechanical joint for you, which means it'll stop the components falling out and moving around, but it won't make a good electrical joint. It's like if you were to push two bits of metal against each other, you would get an electric current would pass between them, but eventually you'd get like an oxide layer build up between those components, which would stop it working, and that's not a good thing. And that's what a dry joint is, where it worked to start with just by kind of mechanical contact, but it'll fail as the oxide layer, as an oxide layer builds up and stops the electrical contact working. So the best way to deal with this is, in this particular instance, there's too much solder on there. So clean my soldering iron, put some solder on, because I still want to make a heat contact and a good mechanical contact, and then heat that up. There's way too much solder and it's not coming off. So what we do then is we have to literally flick the soldering iron. I normally do this into a bin, but I'll do it here for now, to get any excess solder, and you just have to keep doing that until you get any excess solder off you want. And then when you're pretty sure you've got the excess solder off, you can go with a bit more clean solder. Which will have flux in, and the flux is important because solder on its own will not flow very well. But solder with flux, which is what this is, works because the flux effectively melts and it cleans the oxide layer off. It's like an acid really, and it cleans the oxide layer off between the components, and that joint there is kind of repaired. So what was potentially a bad dry joint has now become a good one. So put some solder on there. Do the rest of these little guys. And there you go. The other thing that can sometimes happen, I'll simulate this, wouldn't normally do this, is you'll get this situation where you've bridged two joints. So again, you have to make sure you haven't got too much solder on your iron, so clean it off. And then it's just a case of literally trying to get some off and do this. Now if that's not working, the other thing you have to resort to is a desoldering pump, and then you can just heat that up and Bob's your uncle. Now that will generally take pretty much most of the solder away. So you're not going to have a nicely finished board then until you then just go back in and just individually, more carefully this time, finish off those two components. I haven't done that one at the back. Don't worry, this is a demo board, I'm not going to be sending this out to anyone. Yep, and there you go. That's back to how it should be. I'm taking the blue tack off now that we're using for the demonstration. Well, thank you for watching. Hopefully this video has been some use to you. If it has, why not give me a like? Thank you.